Okay, Gagan, I am started recording.
Yes, sir. Thank
So
you.
this is the flyback converter. Are you able to see image?
Yes, sir. Yes, sir.
So this VI is the input voltage and this is the primary side of the transformer. And this Q is the switch, any switch. It can be MOSFET, it can be IGBT or it can be thyristor, any switch. This is the secondary side of the transformer. This is the diode, capacitor and R load. So when this switch is on, you first you see this polarity, upper dot terminal, this dot and this dot. If this first dot is positive, then this side dot will be positive. So when switch will be on, current will flow in this direction. So this terminal will be positive. If this is the positive, this diode will be reverse bias, so secondary will not conduct, so only primary will charge. So you can see the Vp will be the inductor voltage. So inductor voltage or transformer voltage will be the primary side voltage. This Vi. From this for this lab session, uh, you understand this. I am saying this transformer voltage. So is it? It is only the primary side voltage, not secondary side. You can do on secondary side also, but for my understanding, I am taking primary side. All the quantities I will refer to the primary side. So when switch will be on, the voltage across the transformer will be the input voltage, and when switch will be off, the secondary voltage of the transformer will be V naught. But if you refer the secondary voltage to the primary side, then it will be V naught by N. Are you getting?
Yes, sir.
This will be V naught by N. Similarly, here I am considering flux or current, we can say. So here I am considering flux. When switch will be on, because in case of transformer, flux will be constant. So if you take the current, if you take the primary side current, it is different than the secondary side current. So sometimes it will conduct, sometimes it will not conduct. So if you take the flux, we can able to understand. So when switch will be on, flux will be increasing. So from the formula E is equal to n d phi by dt, we will get what we can say, um, that flux linkages. So Vi by Np. In case of discharging time, this flux will be decreased. So that will be minus V naught by Ns. Okay, and it will follow the pattern. So now we will consider the switch current. When switch is on, the current will flow through the primary side of the transformer and through switch. So what is the current? Vi by L. The slope of the current will be Vi by L, and the switch current will be Iq. When switch is off, no current will flow through the switch. So this will be 0. Again, when the switch will on, the current will flow through the switch and the slope will be like this. The average current of the switch will be equal to the input current. Similarly, we can take the diode condition, but diode is 180-degree inverted with switch. When switch will on, diode will be off. So the current of the diode when switch is on, it is 0. When switch will off, diode will conduct and the current of the diode will be some peaky with this decreasing slope. The average current of the diode will be output current, and this is the capacitor current waveform. The ripple in the diode current will be absorbed by the capacitor. We can see This is the average current. If you do the minus of this actual current from average current, you will get the pattern of capacitor current. And if you take the average value of this capacitor current, it will be 0. And the RMS current will come something. So now we will go for the volt second balance. So when switch will be on, input side voltage will be VI, means input voltage, and during turn on time, so we will denote as DTS plus. When switch will be off, the secondary side voltage will be V naught, and if you refer the secondary side voltage to primary side, then it will be V naught by N into 1 minus DTS is equal to 0. So the output voltage will be N times Vi into D by 1 minus D. So the voltage gain V naught by Vi, means output by input, will be N times D by 1 minus D. Okay.
Yes, sir.
Are you getting anything? If you are not getting, then please let me know. So now we can do this exercise. I think you have solved this problem during what we can say your tutorial
Tutorial.
questions.
Yes, sir.
Hmm. So a regulated flyback converter has to be designed with the following specification. VD will be 48 volt, V0 will be 5 volt, the turns ratio N1 by N2 is equal to 4, and Fs is equal to 100 kilowatts. The load power is varying between 15 to 50 watt. Find the minimum inductance for continuous conduction mode, and the voltage if the output voltage ripple has to be kept 5%, find the value of minimum filter capacitor. So first we have to determine the minimum inductance that will keep the converter is in continuous conduction mode. Okay, so this is the problem. I think you have this answer. So from volt second balance, we get the voltage gain V naught by V in is equal to D by 1 minus D into N2 by N1. If you keep the value, you will get D is equal to 0.294. Now, in order to determine the inductance value, we will take power is equal to 15 watt. Why we are taking 15 watt? Can anybody tell? Because we have two power, 15 watt and 50 watt. So why we are taking 15 watt?
To get minimum value of inductance, I think.
At minimum value of inductance? Hmm?
So power, if should be in continuous conduction mode, then we can. I think if it is maximum, so maybe discontinuous mode.
We take maximum 15 watt because in case we take the 10 watt and power goes to 15 watt, current will increase, which will make it in discontinuous conduction.
Hmm.
So maybe that's why we take maximum
Hmm.
power and we'll get the
Yes, yes.
minimum inductance.
Hmm. Yes. So that is the reason. So we have taken 15 watt power. So according to 15 watt, I naught will be 15 by 5. So we because we have to buck it up to 5 volt. So current is coming 3 ampere. So 50 watt corresponding to 50 watt, the current will be 10 ampere. So in order to design the inductor, we have only one formula. VL is equal to LdI by dt. So any voltage we can take here. Turn on voltage also, turn off voltage also. Only we have to see which quantity we are referring on what side. I always take the primary side. That's why I am also taking the primary side voltage. So during turn off time, primary side voltage will be N1 by N2 into V2. You can see from this image. V naught by N. So V naught by N. So N means N2. And primary side turns I have taken 1. So it is N2 by N1. But if you transform the output side voltage into primary side, then it will be 1 by N. So it will be N1 by N2 into V2 is equal to Lm delta I by 1 minus dTs. The minimum inductance will be, if you transfer all the quantities on one side, so N1 by N2 into V2 into 1 minus dTs divided by, in case of, in what is the question we have said, minimum inductance for continuous conduction mode. Minimum inductance at continuous conduction mode means boundary condition. So at boundary condition, we know the ripple will be 2 times the average current ripple. Okay. So if we keep IL average is equal to 2 times of, means delta is equal to 2 times of IL average. So N1 by N2 into V2. Now what we will do, this IL average we have taken 2 times of I naught, but this I naught is on secondary side. So we have to refer it back to the primary side. So here also we have to keep N2 by N1, and 1 minus D term will come. So that will go up. So it will be 1 minus D square into TS. So it will become V naught. It will become L minimum is equal to V naught 1 minus D square divided by 2 I naught Fs into N1 by N2 square. So this value will come L minimum is equal to 66.48 microhenry. Similarly, we can calculate the capacitor. Capacitor, we have only one formula, C is equal to IC is equal to C dV by dt. So IC into dt will be the charge. This will be C and this is the delta V. So if you see the triangle, the charge will be dTs into I naught divided by C. So from that we can calculate the C. These answers you have, you can see these formulas. So now we will simulate the flyback converter. Input voltage I have taken 48 volt. This is the transformer parameter. Maximum power I have taken 50 watt, and the frequency I have taken 100 kilohertz because it is operating at 100 kilohertz. Winding 1 voltage will be the 48 volt, and winding 2 voltage will be the 12 volt. Why I have taken 12 volt? Can anybody suggest why I have taken 12 volt?
Ratio 4:1.
Hmm?
Ratio 4:1.
Ratio of 4 is to 1, and if you keep D is equal to 0.5, so we will get maximum voltage at the output, that is 12 volt. So, and if you go beyond 0.5 duty, then we can go up to 0.6 also, but after 0.6 the voltage will goes on decreasing in case of buck boost also or boost also. So we will consider standard condition as 0.5. So I have taken 12 volt at D is equal to 0.5, and the RM we will keep maximum 1 point some 08. This value we can take randomly, but I have taken 1.08 into 10 to the power 6, and this is magnetizing inductance Lm is equal to 66.448. This winding resistance means leakage resistance and leakage inductance I have keep 0 means it is lossless transformer. Okay, so this is the switch, and this is the pulse generator. Period I have keep 1 by 100k, and pulse width is 29. That is coming in our answer. Means pulse width is 29%. This diode is I have kept ideal diode. Forward voltage drop will be 0 volt, and this is the capacitor. We have calculated, and this is the resistance according to the power. So now we will simulate. This is the output voltage. It is coming close to the 5 volt, and I think this is the input current that is increasing, and this is the output current that is decreasing. When output current is conducting LO1, that is input current is 0, and when input current is conducting, the output current is 0. And slope also you can calculate according to the formula VL is equal to L di by dt during turn on. So you will get the maximum to minimum value. This is the and this is the capacitor current. I think direction I have kept reverse. Okay, this is the capacitor current. So this is the question for today's lab. You can solve this question number 3 for assignment for this lab, or assignment, what we can say, lab question is homework. So this question you have to solve and simulate and send before the next week. We can read one's question. A regulated flyback converter has to be designed with following specification. VD is equal to 30 volt. We have to keep 2 windings at the output. One which is of 15 volt output, and second which is of 5 volt output. And turns ratio from primary to secondary winding, it is 6 to 3, and from primary to tertiary winding, it is 6 to 1. The frequency will be 100 kilohertz, and output current of first winding will be 1 ampere, and output current of the secondary winding will be 0.5 ampere. So this, with all this parameter, you have to simulate and send this question. So this will be all for this lab. If anyone is having any doubt, then you can ask. Hello.
Yes, sir. Yes.
Anyone is having any doubt? If no doubt, then we can end the session.
Okay, sir.
Okay. Payal, do you have any doubt? Okay, okay. Then you simulate the question number 3 and send before the next week. Okay.
Yes, sir.
Okay. Then we will end this session now.
Thank you, sir.
Thank you all of you.
Thank you, sir.
Thank you, sir.
Yes, sir.
Thank you,
Thank you,
sir.
sir.